So far, all the row operations we've done have been with real numbers. And we could work with matrices that have complex entries too, so we might have to do row operations with complex numbers. Now, pretty much it's the same. The only thing is we have to remember that if we ever want to divide by a plus bi, that's the same as multiplying by a minus bi over a squared plus b squared. So for example, let's say we want to solve this system of two equations with complex numbers. 1 minus I x1 plus 3i x2 equals minus 2i. Second equation, 2x1 minus I x2 equals 6 plus I. All right, so we put that in an augmented matrix and then proceed. So to get rid of the 1 minus I here, we want to make that a 1. We'll divide by 1 minus I. So row 1 becomes one over 1 minus I times row 1. Which is the same as 1 plus I over 1 squared plus 1 squared row 1, which is 1 plus I over 2 times row 1. 1 squared plus 1 squared comes from the real part and the imaginary part of this complex number, 1 and minus 1. Minus 1 and 1 squared, minus 1 squared and 1 squared are the same, so you don't have to really write minus 1 squared there. So we're going to multiply row 1 by 1 plus I over 2 to get, well, 1 minus I times 1 plus I over 2 is, we've got 1 plus I minus I squared over 2. I squared is negative 1, so minus I squared is plus 1. 1 plus 1 is 2. I minus I is 0, so we've got 2 over 2, which is 1. Which is good, because that's the whole reason we divided by 1 minus I, because we wanted to get a 1 here. Then we have 3i times 1 plus I over 2. So we have 3i over 2. The imaginary part is going to be 3 over 2i. I times I is I squared, so 3i squared over 2 is 3 times negative 1 over 2, which is minus 3 over 2. So that gives us minus 3 halves plus 3 halves I. And then finally minus 2i times 1 plus I over 2 is 2's cancel, and we've got minus I squared. I squared is negative 1, minus I squared is positive 1, so 1 minus I. And then the second row is what it was before, 2 minus I, 6 plus I. All right, let me erase my calculations here so we can do another row operation. All right, now I'd like to see a 0 here underneath the 1. So let's subtract 2 times row 1 from row 2. Row 2 becomes row 2 minus 2 times row 1. So we'll copy down row 1. 1 minus 3 halves plus 3 halves I, 1 minus I. 2 minus 2 ones is 0. Negative I minus 2 times this is negative I minus 2 times negative 3 halves plus 3 halves I. this 2 cancels the 2's in the denominator, so we can get rid of that, and that, and that. So we've got negative I plus 3 minus 3I. So the real part is plus 3. The imaginary part is negative I minus 3I, so I guess minus 4I altogether. And then 6 plus I minus 2 times 1 minus I is 6 minus 2, 4. I minus 2 times negative I is I plus 2I, which is 3I. Alright, now we'd like to have a 1 in this position. So we'll divide the second row by 3 minus 4I. Now dividing by 3 minus 4I is the same as multiplying by 3 plus 4I divided by 3 squared plus 4 squared. 9 and 16 is 25, so that turns out to be 25 on the bottom. Oh, equals that times row 2. Or 3 plus 4I over 25 times row 2. Alright, we have 3 minus 4I times 3 plus 4I over 25 is 9 plus 12I minus 12I. I guess I didn't even really need to write that. That's 0 minus 16I squared all over 25. I squared is negative 1, so negative I squared is 1, so it's 9 plus 16, which is 25 over 25, which is 1, which is good, because the whole reason that we divided by 3 minus 4i is because we wanted to get a 1 here. So now we have, well, the first row was 1, minus 3 halves plus 3 halves I. One minus I. And the second row is 0, 1, and we have 4 plus 3I times three plus 4I all over 25. So that's 12 plus 16I plus 3I times 3 plus 9I plus 3I times 4I plus 12I squared, which is minus 12, all over 25. 12 and minus 12 cancel, and we've got 16I plus 9I is 25I over 25, so that's just I. Alright, from the second equation, which is x2 equals I, we can see that x2 equals I. And then if we plug that into the first equation, the first equation is now x1 minus 3, let's say plus minus 3 halves plus 3 halves I times x2, which is I, equals 1 minus I. So that means that x1 equals 1 minus I. We've got minus 3/2 on this side, so it becomes plus 3/2 on the other side. 3/2 I squared here, which is minus 3/2. Oops, this was a minus 3/2 I became plus 3/2 I on the other side. And then we've got plus 3/2 I squared here, which is minus 3/2, which becomes plus 3/2 on the other side. And we've got 1 plus 3/2 is 5/2, and then 3/2 I minus I is 1/2 I. So x1 equals, x1 equals 5/2 plus 1/2 I, and x2 equals I. The end.